Section 5.8 is discussing radical equations and radical inequalities. A radical equation is an equation that contains a radical, like the one you see, square root of x minus 3 equals 4. The goal in solving a radical equation is the same as solving most equations. We need to isolate the variable. So the first thing that we'll do is square both sides of this equation, and the result will be x minus 3 equals 16. Then we'll solve for x. It's very, very important that you check your answers in this section. If it does not work, it's called an extraneous solution, and you'll write no solution for your answer. So let's solve for x in this particular case. There are several steps. We're going to simplify the expression, then isolate one of the radicals, then square both sides, and then solve the equation. So step number 1, we're going to isolate or simplify, by adding the 3 square root of x plus 3's and the 4 square root of x plus 3's and adding them together so that we have 7 square root of x plus 3 equals 28. Step 2, we're going to isolate that radical, so we'll divide both sides by 7, and that leaves us with the square root of x plus 3 equals 4. And then step 3, we're going to square both sides of the equation. And step 4 is to isolate x. And we have a result of x equals 13. Again, remember, you need to check this. This solution is, in fact, a true solution, so it's not extraneous, and we would write x equals 13. Here's another one. 6 square root of 2x minus 13 equals 18. The first thing we do is divide both sides by 6. Then we'll square both sides, add 13, divide by 2, and check our answer. Solving radical inequalities is similar to solving rational equations, but there's one extra step. Since we have to make sure that what's underneath the radical is a real number, we need the radicand, or what's underneath, to be greater than or equal to 0. So our first step will always be to set that piece that's underneath the radical greater than or equal to 0 and solve for the variable. So in example 1, we want to solve the square root of x plus 2 is greater than or equal to negative 3. So since the radical must be a real number, we're going to set the x plus 2 greater than or equal to 0 and solve for this first. So we know for a fact that x has to be greater than or equal to negative 2. Now we'll take this equation inequality, and we'll square both sides. Since the radical is already isolated, it's alone on one side, we'll square both sides, getting a result of x plus 2 is greater than or equal to 9. And then we'll solve for x. We know that both x is greater than or equal to negative 2 and x greater than or equal to 7 both have to be true. So the x greater than or equal to 7 covers both of those. So the answer is x greater than or equal to 7. Now here again, we're going to check our work. So we'll choose a number that's greater than or equal to 7. I've chosen 8 here. We replace the 8 into the original problem and solve, and we get a true answer. Here's another example. Square root of x plus 2 minus the square root of x greater than or equal to negative 3. Since each radical must be a real number, we need to take both of those radicands and set them greater than or equal to 0. So we'll first look at the x plus 2, and when we solve for x, we get x is greater than or equal to negative 2. For the other, we'll take the x and set it greater than or equal to 0. Again, that will cover both of those. If x is greater than or equal to 0 and greater than or equal to negative 2, x greater than or equal to 0 makes them both real. So now we're going to solve. We do the first step, which is to isolate one of the radicals. So in this particular case, we're going to isolate the square root of x plus 2 by adding the square root of x to both sides. Now we can square both sides of this equation. Don't forget that that second side, the side to the right, has to be FOILed. Once we do that, we'll get x plus 2 is greater than or equal to 9 minus 6x, minus the 6, the square root of x, plus x. Now we're going to continue. We're going to isolate the variable again. So in this particular case, we moved that constant over, which left us negative 7 greater than or equal to negative 6 square root of x. Now we're going to square both sides. And that gives us 49 is greater than or equal to 36x. We'll divide both sides by 36. And we could leave this for an exact answer of 49 over 36 is greater than or equal to x. Or we could give ourselves an approximate answer of 1.3611 is greater than or equal to x. Now we're going to check our answer by picking a number that is in our range. Now remember, we had said originally that x was greater than or equal to 0. We also found that x is less than or equal to 1.3611. So that means that it's between 0 and 1.3611. Okay, so we have to give that as our final solution if in fact we get it to check out. So we're going to pick a number that's between 0 and 1.3611. 1 is a nice, easy number to pick. We place it back into the original problem and check, and it checks out.